Hello, this is Mr. Stansbury. I'm going to take you through the notes on trapezoids. At the end of this, you should be able to say, I can develop properties of trapezoids. Okay, so first thing, what is a trapezoid? Trapezoid is a quadrilateral with two parallel sides, which we call the bases, and then two non-parallel sides, which are called the legs. Okay, so here's our two parallel sides. Those are called the bases. Here's our two non-parallel sides. Those are called the legs. Okay. An important property of trapezoid is that the consecutive angles of the legs are supplementary. So basically, if you get the leg and you add up the two angles that connect to the bases, so this angle plus this angle will equal 180, and then also this angle plus this angle here will also equal 180. Okay? An isosceles trapezoid is a trapezoid where the legs are also congruent. Okay, so the base sides are still parallel, and then these legs are congruent. That's called an isosceles trapezoid. Okay. All right. Coordinate geometry formulas. So we're going to need these to show some stuff about trapezoids. So we've gone over these before, but I just thought I'd put them up here so that we can use these when we're going through figuring some stuff out. Okay, so distance formula, midpoint formula, slope formula. Okay, these are going to be very useful throughout the rest of this unit here. All right, so example, plot the points C, O, L, and D, and then show that the quadrilateral cold is an isosceles trapezoid. Okay, so let's plot those points. C is at 1, 0, so there's C. O is at 2, 2. Okay, I'm not sure what this is going to look like, so I'll put the O on there, label O here in a second, and then we got 5, 3. So I'm thinking it's probably that's going to be okay there, C-O-L, and then D is at 7, 2. Okay, so C-O-L and D. So we've got to show that it's an isosceles trapezoid. So, first off, in order for it to be a trapezoid, we have to show that OL is parallel to CD. Okay, so here's what our trapezoid looks like. Okay, so we have to show that this is parallel to this. So, we can't, since we have this graphed already, you can use the slope formula, which is just fine, or we can actually just find the slope on here using our brainiacs here, right? So the rise over the run. So to go from O to L, we go up 1 and then over 1, 2, 3. Okay, so the slope of OL, equals 1/3. Okay, so to get from C to D, we're going to go up 2 and we're going to go over 1, 2, 3, 4, 5, 6. So the slope of CD is up 2 over 6, which reduces to 1/3. So that shows that, first off, that the trapezoid COLD is in fact a the quadrilateral is indeed a trapezoid, because we now know that these two sides are parallel because the slopes are the same, right? That's what parallel means, same slope. Okay, and then let's go through and show that, let's see, we got to show that length CO and LD are the same, right? Okay, so we could use the distance formula on that. Okay, we could do that. Let's just go ahead and do that. So let's do distance equals the square root of, let's see, from C to O. So we're going to do this a couple of different times, right? So C is 1, 0, C to O. So this is, let's call this x1, y1, x2, y2, right? So we can do x2 minus x1. So we've got take 2 minus 1 squared plus y2 minus y1, 2 minus 0 squared, right? So the distance of that first one is going to be 2 minus 1 is 1 squared, 2 minus 0 is 2 squared. So that distance is going to be 1 squared is 1, 2 squared is 4, so that is going to be the square root of 5. Okay, so now let's also do the same thing for L and D. Okay, so let's do our distance from L to D. So let's do that in purple here. We'll call this x1, y1, x2, and y2. All right, so we're going to do our distance on this one, 7, because it's x2 minus x1, so 7 minus 5 squared. And then we got 2 minus 3 squared. Right, so our distance on this 7 minus 5 is going to be 2 squared. 2 minus 3 is negative 1 squared. So 2 squared is 4. Negative 1 times negative 1 is positive 1, so that distance there is also the square root of 5. And since our two distances of these two legs here are the same, that shows that this quadrilateral is not only a trapezoid, but it's an isosceles trapezoid. Now, since these are graphed, there's actually I think an easier way to show that this, show the distance, find the distance here, is we can make this into part of a right triangle, right? So we could say, let's say we'll do this and this. That is a right angle. We know that that's 1 and that's 2, right? So then we could do 1 squared plus 2 squared. A squared plus b squared equals c squared, right? So that's 1 plus 4 equals c squared. So 5 is, c squared. So then we square root both sides, and look, we get c equals the square root of 5, just like we got with that. And you could do the same thing with this. We can make ourselves a little right triangle right here, right? And this right here is a distance of 1. That's a distance, or you already figured out, of 2. So it's the same exact thing. So you'll end up getting that c equals root 5 on that as well. Okay? All right, we're going to do one last problem, but before that, let's take a little comedy break. All right. Last one here. So, reason abstractly, EF. EF is a median of isosceles trapezoid ABCD. So that means that this here, this here is a midpoint of this. F is a midpoint of BC, and E is a midpoint of AD. Okay, so find each measure. X here. So we're going to find what X is. Now, here's something that we need to make sure that we know here. This median here of the isosceles trapezoid, this median here is going to be half of the average of these two sides. Okay, so we take these two sides divided by 2, and it's going to equal what this is. Okay, so this, again, the median is going to be the average of the two bases. So we know that 8x, minus 43 plus 10, that's the two base sides, divide that by 2, and that's going to equal our 2x, right? Okay, so this, I guess we can just simplify this here and see what we get. So 8x plus 43 minus 43 plus 10, so we get 8x, negative 43, and plus 10 is going to be negative 33, all over 2 equals 2x, right? So 8x over 2 is 4x. Negative 33 divided by 2 is what? Minus 16 and a half. Equals 2x. That's a 5. Okay, let's see, let's subtract 4x from both sides. And we get negative 16.5 equals negative 2x. So divide both of these sides here by 2. And we get x equals negative 8.25 for that is what our x is going to equal. Okay, so x equals negative 8.25 Oh, no, sorry, not negative, because we got -2, so that's positive 8.25. Okay. Y, let's see. So let's see, since it's isosceles trapezoid, that means this side's the same as that. Since these are the midpoints of these, that means that all these segments, AE, ED, BF, and FC are all going to be congruent. So that means for this y equals, we can say 6y minus 1 has to equal 2y plus 3. And now we just solve, right? Subtract 2y from both sides, and we get 4y minus 1 equals 3. Add 1 to both sides. 4y equals 4, divide by 4. And y is 1. Okay. So AE, since we now know that y is 1, so we go 2 times 1 is 2, plus 3 is 5, so AE has to equal 5. ED is also going to equal 5. All of these here are going to equal 5, right? BF, so from B to F is also 5. F to C is also 5. A to B, since we know X is 8.25, we can just plug in our 8.25 for this X here. So let's do that over here. 8 times 8.25 minus 43. So let's see. Let's get our calculator to help us out on that one. So we got 8 times 8.25. And then we're going to minus 40, subtract 43. And we get that is going to be, AB is going to be 23. Okay, so then EF is going to be 2 times 8.25. That's 16 plus another half is 16 and a half. Okay, all right, that's all there is for this here. If you have any further questions on any of this stuff on trapezoids, please feel free to ask in class. Thanks.